Okay, guys, here we go again. We're going to start with lesson 2 right now. I'm going to give you the notes you need. I'm going to introduce to you how to do this well. Okay, so chapter 1, lesson 2, ratios. The essential question for this lesson, again, it goes with the chapter. How do you use equivalent rates in the real world? There are 2 goals for this lesson. You're going to write a ratio in simplest form, and you're going to use ratios to compare categorical data. Don't worry if you understand what these 2 words mean. I will explain them a little later. All right, vocabulary. There is one vocabulary word for this lesson. It is the word ratio. I strongly suggest you write the definition down. Use a book definition preferably, because when we get to lesson 4, I do want to start the vocabulary project. It'll be worth a lot of points, and it will help your grade significantly. Okay, so book definition, please. Thank you. All right, so back to goal number 1. Write a ratio in simplest form. All right, let me give you the definition right now. First thing you should know is, what is a ratio? Okay, I'm going to write the word here and the definition on the side. So when you study, you can always look at one side and then kind of cover the answer and say, what's a ratio? You say the answer, then look, oh, got it right. Kind of like a flashcard. Or go the other way around. Give the definition and then, it doesn't work that way, does it? All right, so what's a ratio? According to the book, a ratio is a comparison. Guys, I know my writing's not the best, but I'm getting this right out of the book, so be aware of that. Of 2 quantities by division. Okay, so give you an example. There's something very simple. Now, I know it says quantity, right? Comparison of 2 quantities. But if you remember in the video, quantity, it might be a little confusing. You might be thinking less than, more than. So just think of a relationship. Ratio, relation, right? Relation, relationship. How are they connected? Right? Okay, so if I ask you, give me the ratio of triangles to squares, what is it? Well, you're going to count. Again, please get in this habit. When you write ratios, please write the words. It's asking for triangles to squares. And this is a division bar. Keep that in mind. This little bar here is a division. Okay, so here's the question, and hopefully here's the answer. Well, literally, just count. How many triangles do we have? We have 3 triangles. 3 triangles to 4 squares. And that's the relationship. 3 to 4. For every 3 triangles, 4 squares. I forgot I was going to say rectangles. All right. So it's a relationship. But keep in mind, you can also write it 2 other ways. So you can write it as 3 to 4 with a colon, or with the word 3 to 4 with the word. Okay? So 2 more ways to write it. Okay? And I got some new highlighters. I want to use them. And it, it just makes things look nice too. So, and don't forget that this is a division bar. Also called a fraction bar, either way. fraction bar, division bar. Okay. Let me just draw a little arrow. Okay. Now, you're going to see this word simplest form. Simplest form, because that's our goal. What does that mean? Simplest form. Now, I like to think of it as smallest group possible. All right, or groups, since we're talking about two things. And by the way, ratios can be written with more than two things. You could be comparing triangles to squares to circles. It can be done that way, but normally it's just with two. It's just easier to compare that way. But you can do it with 3 things, 4 things, 5 things. It just gets messy with more than 2, though. All right, keep that in mind. So, look at that. We have 3 triangles and 4 squares. We can't make it any smaller than that. That's pretty much the smallest group we're going to get. Okay? So, let me give you a situation, a problem that we can work with here. Again, don't forget to fold this paper 1/3 of the way. Again, if you see things as you copy this, and when you review your notes, you notice some things or have some questions about things, write your questions here. That way the next day we can talk about it. Okay? Again, the more you put into this, the more you'll get out. Or you want to get an A, you want to get a B, you got to work it. Okay? So here we go. This is page 20. Example number 1. Literally, I'm just copying right out of the book. I'm going to help you out here. It says, write the ratio in simplest form that compares the number of red paper clips to the number of blue paper clips. Then explain its meaning. All right. So we're comparing. Remember what I said? Write the words. Don't just write the numbers. Write the words first. Why am I asking you to write the words first? I'll even write it down here. Write words first to avoid confusion later. Trust me, if you go too fast, you'll mix the order of the numbers up and you'll get the wrong answer. It'll be the right numbers, but in the wrong order. What should be on top will be on the bottom. What's on the bottom, that should be on the top. It just gets mixed up. So here we go. Let me read the problem again. Write the ratio in simplest form that compares the number of red paper clips to blue paper clips. Okay, again, I'm going to use pencil because you should be using pencil for math. All right, so red paper clips to blue paper clips. All right. Okay, it looks like dips. Like I said, that's why we have erasers. All right, let's look at the picture. Red paper clips. We have 2 paper clips that are red, and we have 1, 2, 3, 4, 5, 6. All right. We have 2 red paper clips, as you saw, and 6 blue paper clips. All right. Now the thing is, we have a fraction. And the question is, we want it in simplest form. Can we make this groups smaller? All right. Now, I know red is pink, but bear with me. So let's just do this. Let me draw that division bar. 2 to 6. Can we make these groups smaller so that we have equal groups? So for example, here you go. Just play with it. I have 2 here. Can I break this up? Can I make groups of 1 out of this? Sure. I can make group 1 there, group of 1 there. Okay. Pretty good so far. Again, keep in mind, if you haven't guessed already, you're going to be using GCF and LCM a lot. So what I just did, I have a group of one big group of 2. Can I break it into 2 groups of 1? Yeah, sure, of course. So I have 2 groups of 1. Can I break this up into 2 groups? Well, again, do it in pencil first. I'm pretty sure I can break this up into groups of 3, maybe. I wrote it the way, again, always good to have pencil. 1, 2, 3, 1, 2, 3. And I'm going to draw my fraction bar. Huh. So look at that. It looks like I can break down 2 to the 6th. And the smallest group possible would be 1 to 3. What just happened mathematically? You're looking for the GCF between 2 and 6. What's the smallest equal groups I can make out of this, right? Or what's the most groups I can make that are equal? All right. Now look, 2 and 6. If you remember GCF, again, let me quick reminder. When we did this before, the GCF is 2. Now remember, what that means, either you can make groups of 2 or 2 groups. In this case, this is saying we can make 2 groups. So we divide by 2. And here's the proof. That means we can make one group of 1 and one group of 3, but you get that twice. And you saw the proof right here. So the simplest, smallest group is 1 to 3. I mean, look at this. We have 2 to 6. I broke it down into 2 groups of 1 to 3, 1 to 3. 2 groups. 2 groups. Okay. I know, maybe I'm using too much color here, but 2 groups. Here's my 1 group. Here's my 2 groups. That's what simplest form is. You have your ratio. First, write your ratio. Make sure you have it right. Write the words first so you know what you're comparing. Write the numbers. And see if you can make the group smaller. See if there's a GCF. Okay? Is there a factor that you can use to make the groups smaller? Instead of a group of 2, can I make groups of 1? Yeah. If I divide this by 2, if I split this up into 2 groups, boom. Split this into 2 groups, I have groups of 3. Right? It really is that simple. Do not make it harder than it has to be. I'll do letter A. Got it. This is got it. Still page 8. Letter A. Just to show you what it looks like, in case you're wondering. Yeah, the answer is there, but that's not the point. The point is, you gotta know how to do the work. So write the ratio in simplest form that compares the number of suns to the number of moons, then explain its meaning. Again, first thing, write the words first. Write the words first. Suns. Now I know I'm being hypocritical, so keep using pencil, keep using pencil. I'm using back and forth pen. The thing is, sometimes with pencil, you may not be able to see it, and so pen is obviously better sometimes. All right, so here's the picture. Suns would be the big orange things, or reddish, orange-reddish. 4 suns. How many moons? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, you can see the answer. That's okay. So, again, you don't have to keep drawing pictures for everything, but I want you to see where I'm coming from, okay? 4 to 6. And I'm going to draw a moon like this. Looks like a banana, but or a chile. Depends how you want to look at it. Again, I'm not an artist, but you get the idea. Definitely, you know that they're different things. 1, 2, 3, 4, 5, 6. Okay. We have one big group of 4, one big group of 6. Can I break this up into equal groups? Right? I can make groups of 2 out of this, right? So I can have 2 groups of 2. Can I make groups of 2 out of 6? Sure. And then it'll give me groups of 3 each, right? Well, again, just play with it. Just like with GCF, play with it. I can make two groups of 2. And if I have 6, can I make groups of 2 out of it? Sure, let's play it. And again, if it's wrong, you can always erase it. But it looks like it works out, right? One big group becomes 2 groups. But how did that work with the math? 4 and 6. Again, we're looking for the GCF. Can we make this smaller? Can we break this up into groups? Again, GCF, you're breaking something apart into groups. And already said 2. How many groups of 2 can I make out of 4? 2. How many groups of 6 can I make out of 2? Sorry. How many groups of 2 can I make out of 6? Learn some English, man. 2 to 3. And this divided by 2 means I made 2 groups. The one group became 2. Okay, let me show you the proof over here on the side, if you don't believe me where I got that 2 from. No, sorry, it's not that you don't believe me, but you need proof. Which, you know what, I don't blame you. I told you from the very beginning, be skeptical. Don't believe everything people tell you. Question it. It's okay to say, show me the proof. So I'm showing you the proof. They have a 1 in common, they have a 2 in common, and that's it. The GCF, just like in the previous problem, either you're going to make groups of 2, right? Or 2 groups. And I'll even write the word group of 2 or 2 groups. Oof, a little sloppy there, but you get the idea. All right? That's literally what you're doing. When you're dividing, you're saying, I have one big group, I want to break this up into smaller groups. And that's what we did. We broke up the 4, we broke up the 6, and there you go. All right. This leads us to goal number 2. By the way, guys, it would be easy for me to make Google Slides out of this and just have you watch and just learn it. But there is something to be said about taking paper and pencil or pen and writing stuff down. I mean, even if you like drawing, there's that feeling you get drawing on paper as opposed to using a computer screen. My daughter does both, and she says she still likes getting paper and pencil out. It's just something about the feel of paper, the smell of it. It's just, I don't know. Maybe I'm being weird. But I do know this. The fact that you're using your hands, engaging your hands, engaging your eyes, it makes you, it'll help you memorize it better, okay? I realize it's a lot of work. Some of you don't want to sit here it's already been 20 minutes. Some of you are just sitting here, oh my goodness. But here's the thing, you can do this at home, and you can pause it, you can take a break, and come back to it, you know? I'd rather do this. This is what I want to do. I want you to do this at home. So in class, instead of wasting time having you copy, you can ask questions. Hey, I copied it. I did what you asked me to do. I don't get it. And you can ask me. We have more time to ask. We have more time in class for you to ask me, basically. So just do the work. Give it a shot. It can't hurt to copy, right? All right. So here we go. Use ratios to compare. Let me close that. Oh, geez, sorry about that. Use ratios to compare categorical data. Let me define a couple things for you. Categorical data. Data would be numbers in this case. Data would be numbers. What kind of numbers? Depends on what you're talking about. How many people like chocolate cake? How many people drove on the freeway yesterday? Okay? And actually that leads to categorical. They go together. Categorical would be different types of data. And again, I'm giving you a definition that I understand. If you want to look it up for yourself and write down a technical definition, that's fine. But remember when we talked about the Feynman technique, the goal is to make things simple so they can understand it, so you can explain it to somebody else. So categorical data, again, how many people like gum? What? But let's break it down by flavors, right? The category would be flavors of gum. Mint, spearmint, I like mint, that's all I eat really. Fruit, chili gum? I don't know if that's a thing, but either way. So you're going to use ratios to compare numbers, basically. Let me actually write that down. You will use ratios to compare, and I know it may sound a little lame, like this is kindergarten stuff. Well, yeah, after I explain it to you, to compare numbers about stuff. What kind of stuff? Depends what you're talking about. Again, let's look at example number 2. This is example number 2, page 21. Okay, I'm going to read the problem to you. Several students named their favorite flavor of gum. Write the ratio that compares the number who chose fruit to the total number of students. Fruit to the total number of students. Okay, all right. Write the ratio. Fruit, gum, to total people. And there's the table. All right. How many people actually like fruit? Gum, according to the table right here, 3 people. 3 people like fruit gum. But then what's the total number of people? Again, you look at the table. This is all stuff you can do. If you can count, if you can skip count, you can do this. All right. So 9 people like peppermint. 8 people like cinnamon. So peppermint, cinnamon, that's 17 people so far. Plus 3 more that like fruit, that's 20. Plus 1 person that likes spearmint, that's 21. 3 to 21. Okay, now, this leads us actually, you might have noticed something already with ratios. There is, let me write this on the side. There are part-to-part ratios, part-to-whole ratios, and the other way around, whole-to-part ratios. Honestly, if this doesn't make sense to you now, it will. The more examples you do, the more work you do, this will make more sense to you. All right? But if we're talking about gum, just give you a quick example. Part-to-part could be people that like fruit gum to people that like cinnamon gum. This would be a part-to-whole. Part of the people that like fruit, and the total would be the whole, right? Just keep that in mind, part-to-whole. But anyways, back to this. 3 to 21 is our ratio. Can we make the groups smaller? Instead of one big group of 3, can I break this down to something smaller? All right. Now, some of you might see some patterns already. If you know your times tables, you can ask yourself, hey, I noticed that this is 3. I noticed I can make 7 groups of 3 to get 21. There's a connection. Maybe that could be the common factor, right? In other words, 3 times 7 is 21. There's a connection. That's a fact family, right? But let me erase that for just a moment. Shall I draw a picture? No, I think by now you should have the concept down. All right. Common factor. It's a 3, so I can't use 2 as a common factor. I can't make groups out of 2. Sorry, I can't make groups of 2 out of 3. It's just not going to happen. I'll have one group of 2 and then one group of 1. It doesn't work. And if I make groups of 2 out of 21, I'll have 10 groups of 2 and then one group of 1. That doesn't work. What about 3? Can I make groups of 3? Or can I make 3 big groups? Again, let me help you out here so you can see what's going on. Can I make 3 groups? You know what? I know I said I was going to use yellow, but I really like yellow. Let me use a different color. Let me try orange for next time. I'll leave it out, get it ready. Now, do you notice something? 3 groups, 3 groups. Kind of looks equal to me, right? 3. If I break up 3 into 3 groups, that means I'm going to have groups of 1. 1, 1, 1. If I have 21, and I break 21 into 3 groups, again, if you know your times tables, you go backwards. What number, if you have 3 groups of it, will give you 21? What times 3 gives you 21? 7. Right? So what do you think the ratio is when I simplify it? The simplified ratio is 1 to 7, or 1 to 7, or 1 to 7. Now, before I go any further, what does that mean? Again, yes, I'll give you a quiz, and yes, I'm going to ask you for this, but I'm also going to ask you what you understood from this. 1 to 7. Remember, the original ratio was fruit to total. 1 to 7 is the ratio. Let me rewrite this so you can understand it. For every one person who likes fruit gum, and I might be making this more complex than it has to. For every one person who likes fruit gum, that came out of a group of 7, right? I make this way too complex. I'm going to simplify it for you in just a moment. You're like, teacher, that doesn't make any sense. Fair enough. Let me rewrite it. I can make this easier. And you're going to see an expression. Ready? For a part to whole ratio, there's a pattern you can use. Part to ratio pattern. All right? The ratio is 1 to 7, right? Fruit, total, part to whole. You're going to laugh when you see how easy it is. Okay. 1. I'm going to change the fraction bar. I'm going to write 2 words in there. Out of 7. 1 out of 7 people. 1 out of 7 people like fruit gum. The magic pattern to remember is out of. Out of. For a part to whole situation, the pattern to remember is out of. 1 out of, or 2 out, whatever the ratio is, that's the pattern. Now again, compare this to this madness. For every one person who likes fruit gum, this came out of 7 people. That doesn't even sound right. What was I thinking? Going too fast? Possibly. Or did I do it on purpose? No, I went too fast. Again, part to whole pattern, out of. Okay? All right. Let me do the got it. Page 21. By the way, I realize I'm doing these for you, the got it's. That's okay, I don't mind. the intention, and this is what the A students tell me, the B students tell me they do as well, that they do these problems again on their own without looking at the answers. So that's what it takes. You have to go that extra mile. If you just copy this down and don't look at it again until the day before the quiz, I guarantee you're not going to do well. Okay? Look at the notes, do the problems again and again until you understand it. Again, not memorize, understand. All right? 21B. I'll just read it to you first. A pet store sold the animals listed in the table in 1 week. Write the ratio of cats to pets sold that week. Then explain that meaning. Oh my jeez. Apparently I can't read anymore. Let me read it again. A pet store sold the animals listed in the table in 1 week. Write the ratio of cats to pets sold that week. Then explain its meaning. All right. Here's our table. Pets sold. We have 10 birds, 14 dogs, 8 cats. Again, what did I say first? Write the word. Cats to total pets. All right, according to the table, we sold 8 cats, but what's the total? To find the total, the key word there's total, you have to add the numbers. So 10 plus 14 plus 8. 10 plus 14 is 24, plus 8 is 32. If you don't believe me, you can check it out for yourself. 32. Oh, wait a minute. This is a part to whole problem again. Keep that in mind. We're going to need that later on when we make a sentence out of it. All right. Cats. 8 cats, total pets 32. Whew. The question is asking, can we make this into smaller groups? Instead of one big group of 8 and one big group of 32, can we break this down into simplest forms? Right? Simplest form, not forms, excuse me. Can we make it smaller? All right, one more time because I like you guys. Let me show you the work. We need to find the GCF. GCF helps us break numbers down into groups. All right? 1 times 8, 2 times 4. Guys, if you're still with me, you're still hanging on, you have some mammoth stamina. I'm proud of you guys. Keep it up. It's almost over. All right, look at that. We have 1. We can make groups of, we can make 2 groups. We can make 1 group. We can make 4 groups. Or we can make 8 groups. All right, GCF is 8. That means we're going to break down this one group of 8 into 8 groups. And you can't see it. Here you go. And let me draw a line. And of course, you can do the math in your head. Why is he doing that? I want you to understand what's going on. It's not just enough to memorize the algorithm, the math, and just say, you're not a calculator, you're not a robot. You actually have a brain to use. So use it. Think. All right? All right. Instead of one big group, I'm making it into 8 smaller groups. All right. If I'm breaking up 8 into 8 different groups, then by now you probably know it's going to be 1, 1, 1, 1, 1. Because 8 groups of 1 is 8. Whoop, excuse me. I'm thinking ahead. The smallest group is 1, right? All right, 32. Broken up into 8 groups. In other words, if I have 8 groups, what do I have to fill that group up with to get 32? Or what number times 8 gives you 32? Now, if you know your tables, you know it's going to be 4. 4, 4, plus 4, plus 4, plus 4, plus 4. Remember, repeated addition. So in simplest form, we have, just with the math alone, no drawings, you know the greatest common factor is 8. It simplifies to 1/4. Right? So what does this mean? Remember that pattern I said? Out of. Again. out of. Part to whole, out of. 1 out of 4. Now, what are we talking about? Were we talking about fruit, vegetables? No, we were talking about pets. 1 out of 4 pets were gatitos, cats. That's all it is. Seriously. This is all it is. Ratios. It's a relationship. What's the connection? Yes, it's quantity. Yes. But what's the relationship? 1 out of 4 pets were cats. Right? It's funny. It's like the part to whole, hold the part. Did you notice that? Part to whole, hold the part. I don't know if you want to write that down. I'll leave that up to you to decide. Guys, I know it's already been 36 minutes. One more problem, and then we'll be done with that. And you can be ready for the guided practice on your own. Ish. That was a crooked line. All right, this is page 22. And we're going to go over example number 4. Number 4. All right, let me read the problem. Katie wants to divide her 30 flowers into 2 groups so that the ratio is 2 to 3. All right. Okay. Oof. Forgive me, but we're going to have to make some pictures. All right? You're like, I don't get it. What's going on? 30 flowers. I'm just going to draw circles. This might take, what, 1, 2, 3, 4, 5, 10. Doesn't take that long. Again, I like showing pictures. 5, 10, 15, 20, 12. 1, 2, 3, 4, 5, 10, 15, 20, 25. 30 flowers, okay. 30 flowers. I know that much. She has 30 flowers. I want the ratio to be, how can I arrange these flowers so that the ratio is 2 to 3? Okay. All right. Now, why would you want to do this? Why would you want to split these 30 flowers into 2 groups? Maybe these are flowers that go in the front of the house, flowers that go in the back. But the point is, you're making groups of 2 and groups of 3. How many sets of 2 and how many sets of 3 do you need to get to 30? All right. Now, remember what we did earlier with the pictures, with the circles? All right. Here's the deal. You're going to use a bar diagram. A bar diagram. Let's see. Bar diagram. 2 to 3 looks like this. Why did I draw 2 boxes or 2 bars? Okay. It's basically saying, hey, I want 2 groups. You can't see what I'm doing. I want 2 groups to 3 groups. And I'll put it down here. Right? But in my head, I'm thinking, okay, she wants 2 groups to 3 groups. And if you make a story out of this, if you can imagine, these are flower boxes. So my question then is, how many groups do we have? Together, this is 5 groups. Total is 5 groups. Now, some of you might think, well, wait a minute, wait. So we're breaking up 30 flowers, and we're breaking it up, that sounds like a division problem, into 5 groups. Hold on a minute. That means each group has to have 6. Does this work? I'm going to redraw it. 2 groups, 3 groups, that's a total of 5. You can't see what I'm doing. That's okay. There it is. And now I'm saying, hey, that's 2 groups of 6. Why did I go from bars to circles? I like circles better. That means I have 12 flowers here and 18 flowers here. We're almost done. We're almost done. Hang on. Hang on. 12 to 18. Now, let me go to the next page because I need to show you this last step for this problem. We went from 2 to 3 to 12 to 18. Now, if you notice, with this ratio that I wrote, 2 to 3, that's 2 flowers in the front, or 3 flowers down here, top, bottom. That's a total of 5 flowers. Now I'm just playing with the numbers here. I want you to see what's going on. That gives me 5 flowers. This is 30 flowers. So, what happened? I multiplied by 6, right, to get to 30. Yeah? And isn't that what we did here? Isn't that what we did? Didn't we make groups of 6? But let me show you the other way around. Does this simplify to that? Does it? Well, if you divide by 6, right? Yeah, it does. If I have 12 flowers, right, and divided by groups of 6, that means I have 2 groups. If I have 18 flowers divided into groups of 6, that means I have 3 groups. All right? So, bar diagram, I know we're kind of fast. Let me explain it. If you've never seen it before, this might be a big use. This was, in a sense, a very real sense, a GCF kind of problem. Or a mixture of both, depends how you look at it. GCF, LCM, you put it together, you synthesize it, and make it into something new. 30 flowers, I want groups of 2 and groups of 3. I did that. That gives me 5 groups. Well, if I'm taking 30 flowers and breaking it up to 5 groups, that means each group has to be 6. Right? That means I have 12 flowers here, 18 flowers there. And that is the answer. I'm just showing you this part, just so you can see that how it actually works. If another way to look at it. And it does simplify, so you know it works. Basically, I'm verifying my answer. Alright? And I'll put that here. Verify your answer. Check your answer. Alright guys, thank you for hanging out. This has been 44 minutes of stuff done. Again, break it up. Okay?